So we were discussing about parts of speech tagging yesterday, right? One of the applications that we were seeing was this parts of speech tagging, and if you have seen that, we said earlier that like Markov chains basically comes in handy, and this Markov chains and hidden Markov model are both extensions of the finite state automata, and this finite state automata or finite automata is defined by set of finite states and some set of transitions between the states. So we have also seen yesterday about a weighted finite state automata, which is a simple augmentation to this finite state automata. uh, because this is a weighted, okay, only the thing is that we are adding some weight here. So the weight is nothing but, you should understand that that is the probability that we are trying to give, okay. And the probability all the arcs leaving a node must sum to, so discussed yesterday. And we said that like these Markov chains is a special case of this weighted automation, in which the input sequence uniquely determines which state the automation has to go. It means to say that like this is this Markov chain can be applied onto that one, and the ambiguity problems will not see. If a network is has ambiguity, then definitely Markov chains or hidden Markov models cannot come into existence, or they cannot be handy to solve this type of problems. Okay. Uh, so if you want to compute the probability of sequence of states, we have seen earlier about stating the parts of speech, like probability of x1, x2, x3 up to xt, like that, which is equal to the probability of x1. If you see on the screen, it is given, the definition is, or the equation is clearly given here. Probability of x1 followed by x2 followed by x3 followed by like that up to xt, t terms. For example, if it is there, it can be given, the probability can be computed as probability of x1 first term, okay, probability of the occurrence of the first term, then the probability of occurrence of the second term given the first term, that is x2 given x2 x1, then probability of x3 given two consecutive words or events must have occurred like x1 and x2. Similarly, if you wanted to find out like probability of xt given x1, x2, x3, x4, like that, followed by at last xt minus 1. So this is basically we call as a chain rule. And if it is bigrams, then we try to give only occurrence of two words. Okay, how the occurrence is there? Like of course, the first one is probability of x1, probability of x1, x2, x3, like that. If what is the probability of occurrence of that particular sequence? If we give it, then it is the probability of occurrence of the first term into probability of occurrence of the second term given the first term, that is represented as p of x2 given x1, and into probability of occurrence of the third term Am I audible now?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, fine.